except I didn't record that, so now I'm recording it. Okay, so if you're watching this, don't stop before you get to the end, because I made a mistake, and so you'll need to look at the end to figure out what the mistake is, unless you figure out the mistake while you're watching it, in which case you know that you understand and you're doing a good job. All right, so moving on to question 5. Oh, apparently we're doing Verilog.
No.
Let's see.
I ran away.
Ain't prepared for that one.
Imagine. Hot
Nope.
bonus.
Where is...
Solve this.
There we are.
Very long question.
You know, I felt like at Christmas time, the elevator in this building was not, it was erratic. It was like, you never knew what it was going to do. It would either stop on the floor or not. You never knew if the door was going to close or not. And I felt like, and at that point my back was really bad, and I was carrying these computers up and down stairs to help with the DigitalLogic 2 projects. And I felt like I was being punished, that the elevator was running off the programs that the students had made. And I was like, how did this happen? But it was crazy. All right. Find the equivalent impedance as seen by the source if the voltage is 200 angle 20 and the current is 9.25 angle negative 36.3. Does the current lead or lag the voltage? I think I want something else on here? No, I didn't. Okay. All right. I don't have the answer for this. I did it at home, but this was when my computer died, so I don't have the answer written down. My computer didn't die, it just like erased all my work. Okay, so the impedance, equivalent impedance as seen by the source, if the voltage is 200 angle 20 and the current is 9.25 angle negative 36.3. Okay, so this is an example of one that I would say would be a shorter one. So this is not one that would have multiple sources. So all you need to know for this one is, well, we don't know what the load is. So we could try to find equivalent impedance, but we can't because we don't know what it is. So you could do some work with this, but it would be pointless. But instead, all you need to know for this one is that V equals IZ. So if we're trying to see the equivalent impedance as seen by the source, we don't really care what all it's made up of because we know what the current is. And so Z is going to equal V over I, or V is 200 angle 20, and I is 9.25 angle negative 36.3. So 200 angle 20 over 9.25 angle negative 36.3, and I get about 12 plus J about 18, but if I change that to polar, I get 21.6 angle 56.3 21.6 angle 56.3. My units are going to be ohms because impedance is in ohms, regardless of what it's made up of. Does the current lead or lag the voltage? This is the current. Its angle is 56.3. the voltage angle was 20, and so the current leads the voltage because the angle is bigger. Also, if we look at our circuit, we don't know what the load is. I do because I made this problem up. The load is actually resistive. And so this is actually a capacitive circuit. And so I comes before E, so the current leads the voltage, so that works, yes.
Would you be able to solve this circuit if you weren't given either the voltage value or the current value?
You could not.
Okay.
You could only see what the equivalent impedance would be as seen by the load. Because then you're saying, well, I don't care what the load is, it's what it sees. And in which case you would, so actually there was a question about Thevenin, so let's do that. So what is the Thevenin equivalent as seen by the load? So the Thevenin equivalent as seen by the load of this one, that you could be asked. You would have to know what the voltage is, but the Thevenin equivalent impedance as seen by the load. So we would have J40, let me draw this better. So the equivalent impedance as seen by the load. So what would I do here?
Series would be J40 and negative J22, then parallel 24.
So it'd be J40 minus J22 would be J18, because those are in series, and then I would have J18 parallel with 24. So I'd have J18 times 24 over J18 plus 24. And then I'd have whatever that is. And then if I would need to get my Thevenin voltage, I would want to get the voltage across this resistor. And I would probably do this by, if I had what the voltage, I'd have to be given what the voltage was. I'd probably find the current and then just take that current times the resistance to get the Thevenin voltage. Yes?
How do you know which, well, since you find the Thevenin of that load, that's why you make that as the open circuit to find the voltage across?
Yes.
And since if you find the current, well, how would you, if you find the current in the R Thevenin, well, actually, how would you find the current?
So to find to find V Thevenin is V open circuit.
Yeah.
And this is the circuit that I have. So the circuit that I have is simply a series circuit. So I would find the series impedance and then
Okay.
find the current that way.
Oh, okay. Never mind that. Makes sense.
All right? Other questions?
And then you times the current to 24, and from that you know the voltage difference. Okay.
Yep. Other questions?
I have a question.
Sure.
Yes,
The problem before this?
is behind the angle for 36.3.
Oh. Thank you. Yeah. Okay, I misspoke on this one, everybody. I was finding the impedance, and I said it was I, but it was not, it was Z. And so, hold on, let's make sure I answered this correctly. So this is the impedance. Does the current lead or lag the voltage? The current lags. Yeah, the current lags.
So the rule where if you convert a rectangular form and you get the imaginary part negative, isn't that supposed to be capacitive, right?
Yes.
So I converted it into rectangular form and gave me a positive.
And so it's inductive, which it is. Yeah, I said wrong.
Oh, okay.
Yeah, I forgot when I said that. I was going with what my answer was, as, what do they call that? Confirmation bias.
Okay.
Yeah, and so, but my actual circuit has both an inductor and a capacitor in it. It is actually inductive. So if you didn't watch this all the way through, then you had the wrong answer. So for this one, I don't know how to say at the end to watch it all the way through, but
So is it safe always to convert the final impedance to rectangular form?
it is, yes. Yeah, and that's how I used to always do it, because that was the rule I remembered. There were too many rules in there, and the one I remembered is if you take your impedance, A plus or minus JB, and if it's a minus, then that means it's capacitive, and if it's plus, then that means it's inductive, and then from there I would figure everything else out. So yeah, that is exactly how I used to do it. Okay, any other questions? All right.